Hello everyone. After a long time of this channel being dormant, I've decided to revive it after all. I'm thinking of making a series of maths videos to cover the A-level course, and I'll be posting several videos over the coming weeks so that people can revise over the summer holidays, get ready for year 13. So it'll be mainly year 12 material. Let me know if you'd like me to do further maths as well. But yeah, to begin, I wasn't sure what topic to start with, so I just kind of had a look at the student room maths forum and I came across this differentiation question. Here's the question, and everyone was just like, well, use the product rule, use the quotient rule. And of course, that would work, but the person who posted this, they hadn't covered the quotient rule or the product rule yet. It seems like they were on a different course to the EdXL course, and they wanted to find a way to do it purely using the chain rule. So I decided to answer this question using both methods. First, we will go through how it can be answered using the product rule, very quick and simple, and in the latter half, we will go over how it can be answered using just the chain rule. So, hope you guys find this video useful, and if you are an A-level student, we really encourage you to subscribe as I'll be posting regularly over the coming weeks and months. Anyway, without further ado, let's get right into it. As many of the replies pointed out, this question is best answered using the product rule, which states that if I have got a function y of x, and y of x can be written as a product of two other functions, like so, then the derivative of y of x, y dashed, is going to be this. And one way I like to remember this is keep number 1, differentiate number 2. Now differentiate number 1 and keep number 2. The products, you add them together. So we can write our dy by dx as a product. Like so. And if we've got this, then we can differentiate it using the product rule, which will give us x multiplied by the derivative of this function. And that gives me minus 6 times 5 minus 3x squared to the negative 7. But remember, we must also multiply by the derivative of the inner function, which will be negative 6x. Now we've finished writing down this bit. Now we can add on to that u dash of x, which is just going to be 1 times this function here, 5 minus 3x squared to the negative 6. Let's tidy this up now. If we take out a factor of 5 minus 3x squared to the negative 7, then inside this bracket I'm going to have negative 6x times negative 6x, which is 36x squared. And to get this, I will have to multiply this by 5 minus 3x squared. So I will add on 5 minus 3x squared. Let's now simplify the square brackets. We've got a negative 3x squared, a positive 36x squared, which gives us 33x squared plus 5. Finally, we can rewrite the negative power as a denominator. So we get 5 plus 33x squared, all divided by 5 minus 3x squared to the 7. Let's now go over how this question can be answered using the chain rule alone. To differentiate that using only the chain rule is difficult to do if we keep that as a fraction. We need to get it into a form that allows x to interact with the 5 minus 3x squared. So to begin with that, we could start by writing dy by dx in a different form. If we multiply top and bottom by 1 over x, then we get a 1 in the numerator, and our denominator looks like this. Now, that x is still not able to interact with the 5 minus 3x squared because that's got a power of 6. So perhaps we could write 1 over x in a different way. If we wrote it as x to the power of something, all to the power of 6. So what would have to go in this blank space for it to be equal to x to the minus 1? And the answer is negative 1/6. So if we replace 1 over x with x to the negative 1/6 all to the 6th, we get this. And because they have the same power, we could now write it like this. If we now simplify the contents of the square bracket, we get 5x to the negative 1 over 6 minus 3x to the 11 over 6. So that's 2 take away 1 over 6, all to the power 6. And this, of course, could be written as 5x to the negative 1 over 6, take away 3x to the 11 over 6, all to the negative 6. And this form we can differentiate using just the chain rule. So d2y by dx squared is equal to minus 6 times the bracket take away 1 from the power, but remember we must multiply by the derivative of the inner function, and this will give us minus 5 over 6 x to the negative 7 over 6 minus 33 over 6 x to the 5 over 6. Now tidying this up, we have minus 6 multiplied by 5x to the negative 1 over 6, 3x to the 11 over 6, all to the negative 7. But we can take out a factor of minus 1 over 6 from this bracket, which changes this to look like that. And we've got this and this, which cancel perfectly, leaving us with just 5x to the minus 1 over 6 minus 3x to the 11 over 6 to the negative 7 times 5x to the minus 7 over 6 plus 33x to the 5 over 6, which if we wrote as a fraction would look like would look like that. Now, this somewhat resembles the form we are after, but we've got an x to the minus 7 over 6 on this 5, and that's our clue. That tells us that if we multiply by x to the positive 7 over 6, this will disappear. And if we do that for every term, or both numerator and denominator of the fraction, then it will cancel and give us the desired form. So starting off with the numerator, this is plain and simple. We would just get 5, and for this term, x to the 5 over 6 times x to the 7 over 6 gives us 33x to the 12 over 6, which is better known as 2. So 5 plus 33x squared. Our numerator is looking the way we want it to. Now, when we are multiplying the bottom by x to the 7 over 6, we need it in a way that it can access that. So, we're going to have to do the same thing we did here. So, x to the 7 over 6 can be written as x to the something to the 7, and that something is going to be 1 over 6. Now, because they have the same power, we could write this like we did before over here as x to the 1 over 6 multiplied by what was there in the bracket before, all to the 7. And when we multiply out the contents of the square bracket, we get 5 take away 3x to the 12 over 6, which is just 2, all to the 7. The numerator stays the same. And let's move this out of the way. And that's the answer in the form required. And guys, do let me know if you have any suggestions for my next video, any topics you would like me to go over, or any questions that you might have. Feel free to comment below any other ideas as well. Anyway, I hope you found the video useful, and I will see you in the next one. Bye bye.